Hi everyone, am I audible? You can just write yes or no if you can hear me or not. Okay, you can. Great. So yeah, I think all of you should be able to see the question screen and see me as well. So let's get started. Uh, did you take a shot at this problem? How many of you tried coding this problem on your own and were able to successfully do that? You can say yes or no if you could. Okay. So what was your approach? Would you want to write a few lines mentioning your approach? Okay, so while some of you are mentioning your approaches, I'll read this question out. So it says that we are given two strings S and T. Okay. Now it is said that T is generated by random shuffling of string S. It means that, let's say our string S is something like this. It is A, K, J, B, something like that. Okay. Now what we did is, if you read this line, it says that we generated a string T, and this is a string T, and it has been generated by random shuffling. So random shuffling means we have created a permutation of it. Permutation means you have jumbled up the characters. So maybe you have decided to put K as the first character, and then J as the second character, A as the third character, and B as the fourth character. So this is how T has been generated, but there is one more condition, that one more letter has been added in T at a random position. So at any random position of T, let's say at this position or this position or this position, a random character has been added. So let's say a random character Z has been added at this position. Okay. So this is the nature of the two strings which are given to you as an input, right? S and T. Now what we have to do is we have to return the letter that was added to T. So if your input is this and that, can you tell me what should your answer be? Which character is the additional character that has been added inside T for this case? So quite easy to figure out. It's Z, right? If you check, Z is the character which is present in T but not present in S. So our answer should be Z. Everyone here is quite clear with the question, right? Okay, so now let me read the approaches that a lot of you are writing. So somebody is saying take the difference of 2 and return corresponding. Okay, somebody says bit manipulation, and then somebody says hash map. So there are a lot of approaches, and then somebody says ASCII codes, taking XOR, that is same as bit manipulation. You know, usually when such kind of questions are faced by you, it's very important for you to be able to come up with multiple solutions. Why it is important for a software developer to have multiple solutions to a problem? The reason is, when you work for an industry and you have been assigned a project, let's say you have been assigned to develop an application from scratch, then there can be multiple tech stacks that you can choose. There can be multiple design decisions that you can make. There can be multiple data structures that you can choose, right? Now, choosing any of them may lead you to a correct solution, but the important thing is trade-off in between them. So you can have 4 or 5 different solutions which are all correct, functionally correct, but they will have pros and cons. So maybe one solution is better than another solution in terms of time complexity, and it is worse in terms of space complexity, or vice versa. So it is very important for us to be able to compare and contrast the different solutions that we have. Okay, so what we'll do is we'll pick this question and we'll start with a very, very naive solution. Naive, brute force, whatever you say. What can be the most basic solution? For that, if I read the constraints of this question, it very clearly says that SNT consists of lowercase English letters only. Lowercase English letters are just from small a to small z, correct? Now, the easiest thing that I can do is I can pick all the characters from A to Z one by one. Let's say, for example, we have picked A, and now what I can do is I can try to count that how many times A is coming here, how many times A is coming here. So can you tell me the number of times A is coming here? The number of times A is coming here is 1. The number of times A is coming here is also 1. So if these two counts are exactly same, then A is not our answer. So in that case, we will move on to the next character, which is B. Now for B also we will do the same thing. We will count that how many characters here are equal to B. It's 1. How many characters here are equal to B? It's 1. Since the count is same, so B is also not our answer. Then we'll move on to C. How many times C is coming here? 0. How many times C is coming here? 0. So C is also not our answer. So on and on we'll keep going. Finally you will see that when we pick a character Z and find how many times Z is coming here, answer will be 0. In this case, the answer will be 1. Now here the counts differ. The moment you see that the counts are differing, that particular character will be your answer. So this is probably the easiest solution which a human brain can think, because here it clearly says that you just have characters from A to Z. So I simply iterate on all the characters and figure out their counts in both the strings, one after the other. Does this solution make sense? Do you guys get hang of why this solution is right? Yes or no? And also then you can let me know if you feel like you can code this solution. Can you do that? Okay, awesome. So what I'm going to do is, as I told you, I'm going to iterate on all the characters from A to Z. So I'll write a for loop for char C equals to A, C smaller than equal to Z, and C++. If you are wondering how we are doing plus plus for a character, I would say you need to revisit the concept of ASCII values. Every character has an ASCII value. So if you do A plus 1, you will go to B. If you do B plus 1, you will go to C. If you do C plus 1, you will go to D. So on and on, you will go to Z. Okay, now the moment we have picked a character C, the next thing we are supposed to do is we are supposed to find the count of that particular character in string S and string T. So what I'm going to do is I'm going to initialize two variables, count1 which is 0, count2 which is also 0. Count1 should finally be equal to the number of times character C, which currently is A, is coming in S. And similarly count2 should be equal to how many times that character is coming in T. Okay, so for that I have got to iterate on both the strings one by one, and I know I can do that very easily. I can just write a very simple for loop which starts from index 0 and goes on till the last index of string S, correct? And now I can put a very simple condition that, hey, if S of I, if this is equals to C, in this case I am going to do C1++, as simple as that, correct? Now you can imagine that by the time this for loop is over, the value of C1 will be equal to the number of times this character is appearing in string S. Now the same for loop as it is can be written for the next string, which is T. So this time we will go till T dot length, and if we see that T of I is equals to C, we will do C2++, correct? Now by the time you reach at this line number 13, you will have the values of C1 and C2 ready with you, which depicts the number of times character C appeared in S and appeared in T. Now, if you happen to realize that C1 and C2 are not equal, if this is the case, what does it mean? It simply means that the current character C itself is your answer. So maybe what I can do is I can have a char answer declared here, and whenever this condition is true, I can say that, hey, my answer is going to be C, and then after that I can also break. Can I not break? Yes, of course I can break, because if I have got my answer, there is no use of iterating to the next set of characters, because the question clearly said that only one extra letter has been added, right? So here itself I can break. Now all that I need to do is I just need to return my answer, and by that the job should be done. So let's first run our code and see what happens. And now if you try submitting it, you can see that it worked, correct? So this was the implementation of our naive solution. Simple enough, right? How many of you are absolutely clear with the idea here? You can just write yes, no, if you understand that. Yeah, super simple. Okay, now immediately after implementing a solution, what is the next thing that you should do? What is the next thing that you should do after implementing a solution? You should go ahead and try to figure out the time and space complexity, isn't it? Please once again explain. Okay, I'll explain quickly this entire flow once again. See, we are doing nothing here. You understand the question? If you don't understand, please read it once. So we have been given two strings and we have to find the extra character. Okay. So what we are doing is we are picking all the characters from A to Z one by one, and for each character we are finding how many times that character is coming in S and how many times that character is coming in T. So for A, if you find, you will see that A is coming once here and A is coming once here also. So of course A is not the extra character, but the moment you move on to a character like Z, which actually is the extra character, you will see that the counts differ. So this logic, that if we ever get the frequency, C1 and C2 are nothing but frequency of character C. So if we ever see that the frequencies mismatch, in that case our answer is character C, we break and we return the answer. That's it. By the way, I was asking you guys that what should be the next step after implementation. So that should be analysis. Analysis means time and space. So are we using any extra space here? In order to code this question, have I created any extra array or list or map, anything like that? Can you see that? The answer is no, right? But what about time complexity? How much time we are consuming over here? So for that, if you look at this loop, how many times it is running? So how many characters are from A to Z? There are 26 characters, correct? So this loop is going to run for 26 times, but whenever it runs and you come inside, then you run this loop. How many times this loop is going to run? If the length of string S is M, this loop is going to run for M times. And if the length of this string is equal to N, then this loop is going to run for N times. So I can say that whenever I enter inside the outermost for loop, I am going to do M plus N amount of work, because I am iterating M times here and then I am iterating N times here. Okay, so 26 times the outer for loop will run, and whenever it runs, you are doing M plus N amount of work. So total amount of work will be nothing but 26 multiplied by M plus N. You know, because this number 26 is very small, so this complexity is not bad, right? Because character sets are finite. You cannot have infinite character sets. Even if all ASCII characters were allowed, you could have had a number of 256 or something. So this solution is not bad. Although it is a brute force solution, it is not bad because the character set is finite. But maybe what we can do is we can try and come up with something better. We can somehow try to get rid of this multiplier of 26. So some of you suggested using some data structures. How many of you went ahead and used a hash map? Or you feel that now you can use a hash map to solve this problem? You can just say yes if you feel that would be useful in any way. Okay, great. So let's talk about it. See, hash map is a wonderful data structure when it when you think about storing the frequencies of something, right? And what is a hash map? A hash map is nothing but, those of you who know hash map, very good. Those of you who do not know, there is something called as unordered map in C++. This functions very much like a hash map only. And here you have a key value pair. Key can be of any data type. For example, here in this case, we want to store the frequency of every character. We want to store that frequency of A in string S is 2. So let's say this is your string S, which is A, B, C, B, something like that. And let's say your string T is something like this. It is B, B, C, D, A, A. Okay, what should be the answer for this particular input? If your S is this and T is that, what do you think should be the answer? What is that extra character? Of course, it will be D, right? So now, why I'm talking about hash map is because using hash map, we can store frequency of all the characters. So, and I can say something like this, that, hey, you know, in this string, the frequency of A is 2. The frequency of B is 2. The frequency of C is 1. And for every other character, the frequency is 0. For every other character, the frequency is literally 0. So I can just create this kind of frequency table inside a hash map, correct? Now the same thing can be done for T also. So for T, you can build that kind of hash map. And if you build that hash map, it will say that, hey, the frequency of A that I see is 2. The frequency of B that I see is also 2. The frequency of C that I see is 1. The frequency of D is 1. And the frequency of everything else after that is 0. All the way till Z. Once we have both these frequency tables ready with us, then the job is very easy. Because now all that we can do is, we can iterate on all the characters from A to Z, and we can try finding its frequency from this table and that table. So let's say you have your hash map. You can do map.get to get the frequency of a character A, correct? So let's say this is your map 1, which represents the frequency table of S, and you have map 2, which represents the frequency table of T. Correct? So when you write these two lines, what do you get? You get the frequency of A in string S, and you get the frequency of A in string T. And if those two frequencies are matching, then that means A is not the extra character. So you would move on to the next character. The moment you see that for a certain character, the frequencies that you got is different. Like here it is 0, and here it is 1. You can see that here it was 0 and here it was 1. Immediately you can say that, hey, that particular character itself is our answer. So this can be our simple idea. What we are going to do is, we are going to declare two hash maps. The first hash map will store the frequencies of all the characters of S, and it would then start looking something like this. The second hash map will start looking something like this after it has stored all the characters of T. And then we can just iterate on all the characters from A to Z. And if we find a character for which the frequencies differ, then that particular character is going to be our simple answer. What do you say? Is this approach making enough sense? Do you guys agree with the correctness of this approach? Yes or no? Yeah? Okay. So, so what do you say? Can you code it? How many of you can all code this question on your own? Yeah? Okay. Others? Even if hash map is new data structure for you, don't worry, because I am not going to go into intricate details of hash map right now. I'll just tell you that, you know, you can use hash map just like an array. So let me write a very simple code for that. So let's say I declare an unordered map, and it's a map of char comma int, and I'm going to call it frequency 1 because it is going to store the frequencies of my first string, which is S. Now, you know, by default the values or the frequencies are 0. Okay, so if let's say a certain character is not present, the default value for that will be 0. So the moment you do plus plus, it will increment from 0 to 1, and again if you do plus plus, it will become from 1 to 2. That is how it goes on and on and on, right? So what I'm going to do is I'm going to write a very, very simple for loop which will just iterate on my first string. So I smaller than s dot length and I plus plus. Now you can see what this for loop is doing. It is doing nothing. It is just iterating on the string s. So first, when it is at a, I can simply write frequency 1 of a plus plus. And what is a? A is our s of I. So I can do this plus plus. So the moment this line of code is executed, what will happen? That the frequency of a will become 1, right? Now, when you move on to the next index, again you will see it is a. So again, when you do frequency of a plus plus, the frequency will become 1 plus 1, which is 2. So by that way, by the time this particular for loop is over, you will have this kind of table ready with you at your disposal. Okay. You know, I can again copy paste this thing. It's not a good idea to copy paste. Ideally, you should be writing a separate function. I mean, when you are giving interviews or when you are writing production level code, in order to ensure modularity and clean code principles, make sure you write a separate function, because I'm just writing redundant logic here. Okay. So I can have frequency 2, and here I'm going to iterate on t, and I'm going to do frequency 2 of t of I plus plus. Now you'd have understood on your own that by the time this much of code has executed and I reach on line 12, I will have this map and this map, both these maps ready with me, correct? So now all that I can do is I can iterate on all the characters all the way from A till Z, and I can just look for its frequency inside the frequency 1 map and frequency 2 map. So if frequency 1 of C is not equals to frequency 2 of C, if it happens, what does it mean? If it happens, it means that, hey, we have found the extra character, because only the extra character is going to be that which will have different frequency in S and T. So if this condition happens, I can immediately say that my answer is going to be C, and I need to break out of this loop. So let me declare that char answer. And then finally, when I come out of this for loop, I can just go ahead and return the answer, and hopefully the code should run and should also get submitted. Yeah, it works. And it looks like you can see that it was faster. It was little faster than its runtime was approximately 0, which was better than the previous runtime. So we have to justify it by talking about the time complexity. So who's going to tell me the time complexity of it? I'll give you one information that when you use unordered map, then insertions and lookups. So like when you insert something in a map like this, or when you look up for something inside a map, it is generally order of 1. The amortized complexity is order of 1. So you can imagine it is order of 1 always for now, right? So let's do complexity analysis. Can you first tell me that how many times this loop is going to run? If the size of string s is m, this loop is going to run for m times, correct? And if the size of string t is n, this loop is going to run for n times. And how many times this loop is going to run? This is going to run for 26 times in the worst case. So what is your complexity now? Now it is order of m plus n plus 26. And what was it earlier? Earlier it was 26 multiplied by m plus n. But now it is m plus n plus 26. So certainly it sounds to be better than the previous one, and that justifies the better runtime that we have procured over here. Right? Isn't it? What do you say? Yes or no? Does it make sense, the complexity analysis part? Okay, I think Dheeraj has a suggestion. His suggestion is that we can take a simple array of size 26. Yes, you can also do that. That's a very good suggestion actually. So what he's trying to say is that, he's trying to say that we are unnecessarily using this unordered map, because we all know that every character has an ASCII value, okay? And that ASCII value would be something in between 0 to 255, correct? So what we can do is we can build an array which is of size 256, correct? And whenever we have a character, so let's say our character is A, then we can do array1 of A++. So if we do something like this, what happens? What is the ASCII value of small a? Whatever is the ASCII value of small a, at that index a plus plus will happen. So if initially all the values inside this array are 0, the effect will be exactly same that you had in case of a hash map, right? So see, I'll tell you a rule of thumb. The rule of thumb is that whenever you see that your key, in this case your key is a character, and we all know that our character will have values from 0 to 255 only, which is a finite set of value. So whenever there is a finite set of value, in that case you can skip using a map and you can use a simple array like a frequency array, okay? And it will give you faster performance, because in case of unordered maps, if you know how maps function internally, there is a hash code which is computed, and then there is rehashing kind of things that happens. So insertions are, more costly. Here it'll all be order 1. It will be instantaneous. It will be very, very fast. So you can prefer using an array in scenarios like this. This was an important point, by the way. Does this make sense? How many of you get hold of this particular point? Okay, great. Finally, can we do even better? Can we come up with a really, really intelligent... I remember a lot of you talking about solution based on bit manipulation. So can we solve this question using the idea of bit manipulation? Can we do that? Okay, so let's talk about it. There is a bitwise operator which is very well known, and it is called as XOR. How many of you know about what is XOR? You can just write yes or no whether you know about it or not. So how XOR operator functions is, if we have 2 bits, let's say bit 1, by the way, this is the symbol that represents XOR. So if you take B1 XOR B2, then your result will be 0 if both bits are same, correct? But if they are not same, the result will be 1. This is how XOR operation on 2 bits is defined. So if you have 2 bits and both the bits are same, let's say if both are 1 and 1, 1 XOR 1 will be 0. 0 XOR 0 will also be 0. But if this bit is 1 and this bit is 0, or if this bit is 0 and this bit is 1, the result will be 1. This is how XOR operation is defined. Is it clear? Those of you who did not know about XOR operators, Ashutosh and Murad, do you now understand at least the definition part of it? Okay. If we understand the definition part of it, and now if I ask you a very simple question that, hey, let's say we have an integer x, okay? And if you do x XOR x, what will be the value? What will be the answer of this? Let's say the value of x is 5. Now you want to do 5 XOR 5, correct? What is the binary representation of 5? Can somebody type in the binary representation of 5? It is 101, right? So if you do 101 XOR 101, the bits will be XORed one by one. So this one XOR this one. What will be the value of this one XOR this one? We all know that if both the bits are equal, the result will be 0, correct? Similarly, what will be the result of this 0 XOR this 0? 0. And what will be the result of this 1 XOR this 1? This will also be 0. Hey, so what does it mean? It means that if you take XOR of a number with itself, the result is always going to be 0. So I can generalize it and say that x XOR x is always going to be 0 no matter what x is. Is this point absolutely clear to all? So this is the most important thing to understand firstly. Okay, cool. Another question that I would ask you is, let's say there is a number num. If I take the XOR of this number with 0, what will be the result? What is num XOR 0 equal to? Yeah, so num XOR 0 is going to be always equal to num. And this is also very easy to understand. If you ask me how, I'll tell you. Let's say your number had a binary representation like this. Now if you are taking a XOR with 0, so let's say you take a XOR of this with 0, what will happen? We all know that for 0, at each position the bit value will be 0, correct? Now if you have 1 here and if you have 0 here, we all know that the result will be 1 because 1 XOR 0 is 1. Similarly, if you have 1 here and we all know that there will be 0 here for sure, the result will be 1. Now at the places where you have 0 here, of course the result will be 0 here because we all know that all the bits here are 0. Now if here there is a 1, we know that the corresponding bit here will be 0, which is this, and then the result will be 1. So I can say that if you take a XOR of a number with 0, then its carbon copy will be emitted. The exact same number will be emitted. So basically anything with 0 is equal to that thing only. So taking XOR of an item with 0 does not change that item. This is an important thing for you to realize. I know that very few people learn about bitwise operators, so I wanted to make these things clear before I talk about things. Okay, now think of it in this manner. Here in this question, we have been given 2 strings. String S, which is equal to, let's say, AA, CBC, and string T, which is, let's say, equals to ACC, BA and BKA, something like this, right? Okay. Now, what should be the answer here? Which is the character that is extra character? The extra character is K. So our answer should be K. Now, the most important thing which is going to help you to solve this question is this part, which says that XOR of any item with that item itself is equal to 0. How? Let us just understand that. See, if I forget about this K, let's forget about this K for now, okay? Let's say this K was not there. I'm just removing it for a moment. Now if you take a XOR of all these characters with all these characters, what will happen? Let's say you are writing, of course you can't write programmatically like this. You cannot take directly XOR of two strings. You can take it character by character. But if you do that, tell me what will happen. If you want, you can start your journey with a very simple string. Just for convenience, let's say your S is ABC and your T is BAC. See, if you do this, what is your S? Your S has A, B and C. So you will write A XOR B XOR C. And now you will be taking the XOR of this thing with T, and T has BAC. So you will get B XOR A XOR C. Now for every A that is present in S, there will be a corresponding A which is present in T. Correct? For every B which is present in S, there will be a corresponding B which is present in T. For every C which is present in S, there will be a corresponding C which is present in T. And we all know that A XOR A, when this A is XORed with that A, it will result in 0. So I can always rearrange this expression and I can write it like A XOR that A, A XOR that A. And similarly, I can write B XOR that B, correct? And similarly, I can write C XOR that C. Now, all of you can understand it quite clearly that this thing, A XOR A, what is it going to be? It is going to be 0. What is this going to be? It is also going to be 0. What is this going to be? It is also going to be 0. 0 XOR 0 XOR 0, that result is going to be nothing but 0. So it means that if there are two strings such that second string is a mere permutation of the first string, a mere jumbling of the first string, then XOR of all the characters will always give you 0. Why? Because for every character which is there in S, there will be a counterpart in T, and that's why the result of that will be 0, and it will keep happening with all the characters. So you will just get 0 XOR 0 XOR 0 and the result will be 0. Is this point clear to everyone? Are you guys able to follow me on this, that why the result will be 0 if there are two strings such that both of them are permutations of one another? And yes, XOR operation is something which is, it is commutative, you can rearrange it. How you can rearrange addition operation, you can also rearrange XOR operation. See, if I write something like A plus B plus C, then you can rearrange it like A plus C plus B, or in any other order. The same thing can be done with XOR operation also. It can be totally rearranged, right? Cool. Now that we have understood this idea, if I were to ask you a question that, hey, what if there was an additional character D here? So if there was an additional character D here, it would have appeared over here, correct? Now, my question to you is, what was the value of this much part? We just found that out. What was the value of this much part? The value of this much part was 0, correct? And whenever you take XOR of 0 with a number, what is the result? The result is that number itself. So if I take XOR of D with that value, what will I get? I'll get nothing but D. So what does it mean? It means that if I take XOR of all the characters of the two strings, my result is going to be nothing. It is going to be the character that was extra character. Do you get my point? So if I take XOR of all the characters of this and that, I am naturally going to get this K as the answer. Of course, I'll get this K as an integer, and then I can typecast it. I can always typecast it into a character, because every integer value, as long as it represents a correct ASCII value, can be typecasted into a character value. So you know, all that I'm going to do is I'm going to put off this code for now, and I'm going to say that, hey, I'll start with a variable called XOR val, which is initially 0. Why I have initialized it to 0? Because we all know that taking XOR of anything with 0 does not impact the value, right? And now I am going to first take XOR of all the characters of S. For that, I'll have to iterate on S. So I am going to write a code, I equals to 0, I smaller than S dot length, and I plus plus. And all that I'm going to do is I'm going to do XOR val equals to XOR val XOR S of I, right? Correct? It means that by the time this for loop is over, I would have taken XOR of all the characters of S. And now exact same thing can be copy pasted for the second string, which is T. And in this case, we are taking XOR of all the characters of T. So now you can naturally imagine that by the time these two for loops are over, we would have actually taken XOR of all the characters of S and all the characters of T. So this value will be equal to the ASCII value of the additional character, of the extra character, which is nothing but K. So what we can do is, we can return K. But hey, can we return K? No, because K is an integer and we have to return a character. So we can always typecast it into a character, and that merely should be our answer. Let's see if it runs or not. Sorry, it's not K, it's this XOR val. I just copy pasted that. Let's run it. You can see it works, and now if I submit, it gets submitted. And again, it is very, very fast. Let's talk about the time complexity. How many times this loop is going to run? If the length of S is M, this loop is going to run for M times. And how many times this loop is going to run? If the length of this string is T, this loop is going to run for N times. So what is the total complexity? It is M plus N. So it is again slightly better than the previous one, which was M plus N plus 26. Is it clear? How many of you are absolutely clear with this bit manipulation based solution? You can just write a yes or no if you are clear with it. Can you tell the typecasting part? Typecasting part is nothing. See, every character has an ASCII value. Okay, like there can be a character, let's say capital A, whose ASCII value, I think you need to check, I think it's 65 or something. So if you want to convert the number 65, which is an integer, into a character, you have to do a typecasting. Typecasting is a concept of converting one data type to another data type, and that can be done by writing code like this. Learn about it. It's a basic it's a fundamental programming concept which you should know. So how many solutions have we discussed of this problem? Right since the beginning, we have discussed 3 different solutions, right? And now you can see if somebody asks you that, hey, which solution is the best solution? So what would you say? Which one? First, second, or third? It looks like that the third one is best because third one had the best time complexity and it did not use any extra space also. But if you talk about the solution which was based on hash map, that used extra space because when you create an extra map, you're using some extra memory, right? So usually whenever you encounter a problem like this, or for that matter any other problem, try coming up with different solutions and try analyzing the trade-offs, try analyzing the time and space complexity, right? If you have any solution, we can discuss that too. If you want to write about any solution that came to your mind that you worked on, then you can talk about that too, and then maybe we can throw some light over it before we are done. Okay, just in case if you have any, please do not hesitate in typing it in the chat box. You can always type it in the chat box. I will personally look at your solution and I will put my feedbacks on top of that. Okay. When will 1-1 DSA bootcamp start? I'm not sure about it. I think right now that's not planned. We'll let you know if that is in any case. Yeah. Everyone is this helping you out? I mean, Bharat talked to me about this initiative and he told me, why don't you also take one class? So is this initiative working out well for you? Are you guys able to ensure consistency of problem solving or ensure your daily streak of problem solving because of whatever we are doing? There are some questions. What is the complexity of concatenating the two strings? It is something which you should definitely explore. Whenever you concatenate two strings, it does not happen in linear time. All right? It takes some time because if you're talking about languages like Java, in a language like Java, let's say if you have a string which is hello. Now if you do hello plus by, then a copy of this and a copy of that both will be created in memory. So you will have a string called as hello, you will have a string called as by, and you will have another string called as hello by, right? So it's not like it's a constant time operation. It takes time. I mean, for that you need to know that how languages manipulate string, how they store them. That will give you some better idea that how it really happens. Another thing for you to explore, I would say, is that, you know, what people do is, let's say there is a string str, and if they have to concatenate str to something, they write str equals to str plus a. This is one way. Another way is something like this. Can you tell me which way is better? Is this better or is that better? If you don't know about it, try reading about it. And next time whenever I see you guys for a session, and if there is a question pertaining to string, I'll definitely talk about something like this. But do some sort of, you know, self-study on this thing. There is difference between writing this piece of code and that piece of code. One of them behaves better than the other one, okay? And you should know why exactly that is the case, okay? Second one is better. And why second one is better? What is the exact reason behind that? It's something that you should explore, yeah? Okay, great. So I think, cool then. So let's meet again tomorrow. We'll pick something else and we'll talk about that question. Till then, those of you who have not written the code of this question, make sure you do it before you go for the sleep. Okay? Cool then. So that's it. Bye and good night.